What's up? It is Wednesday, April 1st. We made it through March. We are into April. Today, we are going to do the graph that goes with the notes from yesterday. And yes, I do not have my glasses on because I said I was going to wear contacts, but it's so bright out. I can't see anything with the sunglasses, and I need to be able to see. We're making a graph today. So, welcome back. Can we graph an action potential? What are the types of sodium channels that allow sodium into the neuron? You should have stimulus-gated sodium channels and voltage-gated sodium channels. That would be two different neurons. Two neurons? Channels. I apologize. All right. So, if you can recall from yesterday, we went over the action potential. We went through the steps. We're going to take these steps and we're going to graph them. So we have to be able to do the graph. So, I have that same picture, focusing in on the neuron, but we're going to add some stuff here. So I'm going to put a graph over here. Should be good. On the x-axis, we're going to have time, and this is going to be in milliseconds. That's pretty quick. And over here, we're going to have voltage, and that's going to be in millivolts. Okay? Now, do you remember what our starting voltage is? Should be negative 70 millivolts. So we can just draw a line, we start going across like that. Now that can go on and on if it's not stimuli. Stimuli? If it's not stimulus, if there's no stimulus, right? This is annoying. My papers are flying all over the place here. I'm gonna make sure I keep myself organized and not all over the place. All right, so here we go. We are going to do, we'll put a little point over here, right? And we're going to do this. Now, what is that point there? I'm going to put number 1 over here. There's a stimulus. So what does that mean? That means, I'm going to make that a little bit smaller so I can go over. Stimulus gated sodium channels open. So what does that mean? We start to let sodium into the neuron. What does that mean? It means the neuron starts to get more positive, as we could see over here. So we're getting more positive, right? All right, so at negative 55 millivolts, negative 55 millivolts, this is going to be called threshold. Threshold. If threshold is reached, then the voltage-gated sodium channels open, allowing the sodium to just rush into that neuron. So what's going to happen? It's going to get way more positive. If the threshold is reached, voltage gated sodium channels are opened. And this causes the neuron to become more positive. And threshold, by the way, is 55 millivolts. So, if this opens over here, I'm going to use a different color, I think. We can do this, right? And so, what's going to happen is, when these sodium channels open, what am I doing? I'm using green. We are going to get to plus 30 millivolts. And that's really as high as we're going to go. Plus 30 millivolts. And then what's going to happen is you sort of got a little plateau over here. Okay? So what happens at plus 30 millivolts? Plus 30 millivolts, the sodium channels shut. So you have a brief moment where you're kind of staying the same, But while that's taking place, what happens? The voltage-gated potassium channels had open. Remember, those are slow. But since they're open now, the potassium, which is positive, can leave the neuron. Now, if it's leaving the neuron, which was insanely positive, it's going to start to become more negative. So, voltage-gated potassium channels open. Then you start to have your membrane potential start to come down. Membrane potential comes down. We become more negative. But if you see, we went lower than the negative 70 millivolts. And that happens. Bizarre. So what happens? Our good old friend, the sodium-potassium pump, restores resting membrane potential. So then we come back up, and then we're good to go. All right, so if I was to number these over here, you would have your number 1, here's your number 2, here's your number 3, and there is number 4, right? Now, I'm missing a few things. I'm going to get into this over here right now. At number 4, you have your potassium channels shut. I should have said that. The potassium channels are going to shut, and then the sodium-potassium pump can then restore the membrane potential. They can't be open and all that happening at the same time. So let's just take a look here. At negative 70 millivolts, we get a stimulus. If that stimulus, well, the stimulus will cause the stimulus-gated sodium channels to open. If it gets up to negative 55 millivolts, it will reach threshold, and therefore the voltage-gated sodium channels will open. While that's happening, the potassium channels are doing that. They're slow. So once it gets up to plus 30 millivolts, the sodium channels shut, all of them. No more sodium in. Bye-bye. The potassium channels, however, open. So they leave, the voltage-gated potassium channels. The sodiums leave. The membrane potential drops down below negative 70 millivolts. When that happens, the potassium channels, the voltage-gated potassium channels, shut. And then the sodium-potassium pump starts working to restore the membrane potential. While this is going on in this area, between 1 and 4, there could be no other stimulus at that time. And this is in milliseconds, so it's a really short period of time, but it's kind of interesting to think about that. All right, so if we look, we can label these names of these parts. Down here at negative 70 millivolts, the neuron is said to be polarized. Between 1, 2, and 3, going up, we have something called a depolarization. It is depolarized. Going down, we have something called a repolarization. Over here at 4, down here, this is called a refractory period. And then we are polarized again over there. All right, so this is the action potential graph. I went through the steps with you. I did it again on the side over here. You have your resting neuron, gets depolarized, goes up, gets repolarized, refractory period, and then it goes back to being polarized. Now, We can go into a lot of details. Like I said, I teach this like a high school course, but if it was college, right, and we had our neuron over here, that neuron, it has these, color, there we go. It has this over here, right? This is what? The myelin sheath, right? So you can't just have sodium just coming in any old place like that. The sodium can only be brought in those little nodes, the nodes of Ranvier. So when the sodium channels open over there, it's kind of nice because what you get is a nice flow of charge going across. You get an action potential going and going and going and going across the whole where that myelin sheath is, and then you can have another action potential. And again, this myelin sheath insulates it. It allows it to go through really quick. A great analogy that I heard was it would be like if you're in a Word document and you wanted to get over 100 spaces. If there was no myelin sheath, then you'd have to press spacebar, 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 100 times to get there. But with the myelin sheath, it'd be like hitting tab, 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 tab. So this myelin sheath, it insulates it, keeps that action potential going throughout it. Do you need to know that? Not in my class, but you would learn that if you were in a college level class. This graph you need, though, you should like write it down because my worksheets that you're going to have to go with this, they go with the graph. Hope you all had a good April 1st. I'm hoping that I woke up on the news and the government was like, this was the biggest global April Fool's Day ever, and everybody has to go back to school and work. But I think that is obviously insane, and that's not going to happen. So, good thinking, though. You have a great day, and I'll see you tomorrow. Peace! I did it.